Ladies and gentlemen, boys and girls, children of all ages, I'm going to work two of these multiplication problems just because I want to. We're starting our multiplication unit. You were taught in previous years how to do two-digit by one-digit multiplication, but I just want to go over a couple of them and tell you a few things on how it works. Let's look at the first one, which was 83 times 4. Now, one way you can do it is you can break it into expanded form. So I can make 83 80 plus 3, which means I would multiply 80 times 4 and 3 times 4, and then I would add these two products together. Now, if I have a 0 in my ones place, all I have to do is move that over. And then all I'm left with is 4 times 8, which if you have a multiplication table, you can see is 32. So I just take my 0 from my ones place, move it over here, and then all I need to know is one digit by one digit. 4 times 8, and that equals 320. This, 3 times 4, is on your multiplication chart, and we know that equals 12. I can add these two products together, and that'll be my final product. So I get 332 is my final product. Well, let's check it using the standard algorithm. 4 times 3 is 12. I can look at my multiplication chart if I don't know. That's a one digit by one digit multiplication. Now I have 4 times 8, which is a one digit by one digit multiplication. 4 times 8 is 32. And then I add the 10 that I had to carry. That makes it 33. Any multiplication problem you will ever get involving whole numbers, you're only multiplying one digit by one digit at a time. You never have to multiply by more than one digit by one digit at a time. So if you can know your 1 through 9s, or your 0 through 9s, and if you don't know them right now, you can use your multiplication chart. But if you know your 0 through 9s and you can add a one digit number to it, the biggest number you'd have to add is 9. So if you can do the one digit by one digit multiplication and you can add 9, then you can do every single problem you'll get, no matter how big it is. Let's look at the one that was the most difficult. And that one was 41 times 41. And you're all like, what? I don't want to do two digit by two digit. What? That's so hard. Well, again, I'm going to break it down into expanded form. I'm going to take this 41 and I'm going to make it 40 and 1. And now I multiply 40 times 41 and I multiply 41 times 1. We good? 41 times 1 is obviously 41. Now I'm going to put this 0 in my ones place, because that 0's in the ones place, so I'm done with it. So now all I'm really doing is multiplying 41 times 4. 1 times 4 is 4. 4 times 4 is 16. So my product for 40 times 41 is 1,640. Because I took my 0 from my ones place, I moved it down to the ones place, and then all I had to do was my 1 times 4 and my 4 times 4. Then the sum of these two digits, or these two products is going to be my answer. So your answer should have been 1,681, if I did it right. Looking at the standard algorithm, I am still multiplying one digit at a time. I'm multiplying 1, 1 times 1, 1, and I have 1, 1. 1, 1 times 4 tens, and I have 4 tens.
You have 4 tens?
I'm done with my ones place. Now that means I am moving on to my tens place. That is the reason the 0 goes there. Because I'm moving on to my tens place.
Tens place?
Yes, the tens place.
Why?
Now I have 4 times 1, which is 4. 4 times 4, which is 16.
16?
I find the sum of these. And I get the same product, no matter which way I did it. But what I need to emphasize to you to get through your skulls is that you are only multiplying one digit by one digit. That is it. So don't freak out when I give you 326 times 29, because you're still only multiplying one digit by one digit at a time. So please be calm, relax, and you will be fine. Boom, shakalaka, peace out, God bless, love you, do something kind today, save the bees, and I don't know, be a sweet person.